Dear students, in this lecture we are going to see the working principle of K-means clustering algorithm. K-means clustering algorithm is one of the simplest unsupervised clustering algorithm which can able to cluster the unlabeled data into a specific number of clusters. Here a total population is given. We have to group the population into 4 categories. The people in the population can be grouped based on age, location and other criteria. What does K in K-means represent? The K represents number of cluster. Here given some set of unlabeled data point, the K-means algorithm can able to learn the similarity from the unlabeled data and group these data into K clusters. Here the K represents 3. The clustering generally groups the similar data points. As it is an unsupervised algorithm, the model is given with unlabeled data and the number of clusters as input. The model can able to learn the similarity features from the unlabeled data so that these unlabeled data can be assigned to the cluster which has more similarities. In order to calculate the similarity, here Euclidean distance matrix is used. The distance calculated between the data point and the cluster centroid to be minimum to make the data to be grouped into a similar cluster. This animation shows how the unlabeled data are grouped into 3 categories of clusters. K-means clustering is mainly used in target marketing. As you know, the e-commerce websites such as Amazon, Flipkart, they target the audience to sell the particular product. For that purpose, they use the clustering algorithm to group the people based on their profile, purchase history, pattern of purchasing and reviews. This will help them to identify the target audience. The other use of K-means algorithm is in the Netflix. Here the challenge is which video to be shown to the user and which is not to be shown to the user. So the solution, they will group the videos based on the budget and Facebook likes. They are using the approach of K-means clustering algorithm in the background in order to group the user so that they can provide the appropriate videos to the particular group. Here we are going to consider 2 case studies. The first case study is we want to establish a pizza delivery centers across a city. In order to do that, we have collected all the delivery locations where the pizzas are delivered. So here the flag represents the delivery locations. The step 1 is we have to decide the number of clusters. So here the number of clusters represents how many delivery centers we want to establish. So based on that, 3 random points are selected among the data points. The second step is we have to calculate the distance between each data point to the cluster center. So if we consider this is an unlabeled data point, we have to consider the distance between the unlabeled data point to the cluster 1, the same unlabeled data with the cluster 2, and the same unlabeled data with the cluster center 3. So from the 3, which distance is minimum, that distance we have to consider as a more similar to the data point. Like that we have to repeat for the all data points. In step 3, assign the data points to the nearest cluster centers based on the minimum Euclidean distance. Once it is done, in the step 4, we have to recalculate the new centers based on the data points in each cluster. So the new center will be calculated by taking the mean of the data points available in the new cluster. This step will be repeated. The step 3 and the step 4 is repeated until there is no change between the clusters. So in case study 2, we want to establish a de-addiction center. So now a data is given, that is the drug-related crime in Canada. This data contains the crime informations due to the drugs especially for the underage people. Due to this substance abuse, they want to start a de-addiction center in different areas. So with the available data, we have to solve the different objectives. So they are, you want to classify the crimes based on the abuse substances. We want to classify the crimes based on the age groups. So we have to analyze the data so that what kind of de-addiction center can be established. And we have to find out how many de-addiction centers need to be established. So these all analysis can be done by the Kmeans clustering algorithm. So now the Kmeans algorithm is summarized as below. Whatever we have visually seen before, now we have to summarize this algorithm. So let X be the data points, that is the unlabeled data points, and C be the number of clusters. The procedure for Kmeans clustering algorithm is detailed as follows. The step 1, we have to decide how many number of clusters we need, that is the value of K, and we have to randomly select the K cluster center. During step 2, we have to calculate the distance between each unlabeled data point to the cluster center, so that we have to identify the data point belong to which cluster center. It will be decided based on the minimum Euclidean distance. In step 3, we have to assign the data point to the nearest cluster center based on its minimum Euclidean distance. In step 4, we have to calculate the new center for each cluster whatever we have computed. So this new cluster center is calculated by averaging all the data points belong to that cluster. So it represents the arithmetic mean of data points present in that particular cluster. Ti represents the total number of data points present in the ith cluster. So we have to calculate for the K clusters. Step 5, we have to repeat step 3 and step 4 until the global cluster centers are reached, so that there is no changes between two different clusters. This diagram represents the flow diagram of the K-means algorithm. We have to start the algorithm, we have to define the number of clusters, that is in terms of K, and we have to select randomly K cluster centroid. Based on the cluster centroid, we have to identify the distance between every unlabeled data to the cluster centers. Based on the minimum distance, the unlabeled data points are grouped into any one of the cluster, and this procedure is repeated by checking whether the centroid has converged. If the centroid has not converged, again we have to recalculate the new centroid, and based on that we have to classify the unlabeled data points, and again you have to repeat the procedure until the centroid has converged. Now the question is how to decide the value of K. We can use a method called as elbow method. Generally, we will start the algorithm with the number of clusters to be 2. Then we have to do the experiment by changing the number of clusters to 3, 4, 5, 6 like that. So now by using the elbow method, we will get an idea that if we increase the value of K, then the distortion remains constant. So after some point, that is the point elbow, after that if you see here the distortion remains constant. So we can consider this is an ideal value. So this elbow point represents the number of clusters to be created for the particular problem. These are the advantages of using K-means clustering algorithm. It is easy to implement. It is relatively fast and efficient when compared with other clustering algorithm. Here we have only one parameter to be tuned, that is the number of cluster, that is the value of K. Thank you for listening.